As much as I want to cover the recent Rabbit R1 news, which claims that it's all just based on GPT-3 and their large action model is basically fake, what I think is a bit more interesting is we just got another update from Eric Hartford with his efforts fine-tuning Llama 3. Although the performance numbers are maybe not as impressive as we would have hoped, this is another step forward in understanding what the next sort of state-of-the-art starting point in open source local AI is. So earlier this week, we saw his fine-tune of Dolphin 2.9-llama3-70B, and it was interesting to see that the approaches necessary to make this model more performant, or at least more competent in certain areas, was significantly different than that of Mistral 7B or Mixtral 8x7B, or really any Mistral models in general. And what's cool is with a little bit more time passing, we've also seen some other models based on this that are also trying to fine-tune Llama 3 and having mixed success. Basically, the outcome here is that it takes just as much work and that we're going to need different strategies or just different approaches in general when compared to fine-tuning other large language models. And the big thing here is understanding what difference just having a larger model makes. In certain cases, it's actually easier to eke a bit more performance out of these small models, but curiously, since larger models just have more context to draw on, in certain cases, fine-tuning specific skills in them can actually be a bit easier because you have more space to let them focus, and in theory, sometimes you have a larger context window to work with. So today, we're going to be mostly focusing on this Llama 3 fine-tune. This also comes by courtesy of Crusoe Energy and Ethan Peterson for actually quantizing it so we can run this on a Hugging Face endpoint. So we're going to get into if this model is actually more useful than the stock Llama 3-70B, if there are any improvements that have been made since the Dolphin 2.9 fine-tune of Llama 3-8B, and whether or not this is actually uncensored enough to make it competent, and whether or not you can really use it right now off the bat. So welcome to AI Flux. Let's get into it. So just about 12 hours ago, Eric released this, and I think it's pretty interesting what we have to show here. This video is mostly going to be about discussing these benchmarks and discussing some relatively similar prompts on the Hugging Face endpoint. Obviously, check out my video looking at Dolphin 2.9 for Llama 3-8B. I think there's a lot of great insight there, so check that out maybe before you watch this. I'll have it be above in the upper right. And yeah, let's get into it. There's already a GDUF release of this, and it's already on Hugging Face. And what I want to talk about first are these benchmarking numbers here. This is roughly comparing Llama 3-70B instruct and Dolphin 2.9 Llama 3-70B. And I acknowledge that Zuck still wants Llama 3 to be first before the fine-tune name, but I like that Eric is kind of holding strong here and just saying, no, I'm going to do it this way. So more power to him. What's interesting here is the margin in certain benchmarks is, I would say, within margin of error. Margin of error is something that's pretty hard to articulate with a lot of these benchmarks, although I think you can really see it come out when you look at reruns on the LLM leaderboard, which is kind of interesting. But you can see here, like for ARC, for instance, it's hard to say that between 71.4 and 71.6, that's really a performance margin. However, I will say when you look at MMLU, something like Truthful QA, basically whenever there's at least a 2-point spread, I think that's basically an indication that there was a measurable improvement made. And obviously these benchmarks, these representations are done with multiple runs. It's not just picking the best one, because that just wouldn't be very scientific. But also, I think it's important to give maybe a bit more weight to benchmarks that actually represent a larger data set or a larger set of questions and were actually produced by larger companies. And I would say the only kind of exception to this rule is benchmarking done by Nos Research. They're incredibly focused, and I think are probably the least biased of anyone creating these, because they're just creating fine-tunes and they don't really financially benefit from having the best fine-tunes per se. And I think that's also a really cool attribute of open source AI, because, you know, in theory, Eric's not like selling this model. Really interesting data there. And there's also some interesting insight that Eric shared. And I think if you're curious, you should just leave comments under these models, because there's actually a ton to learn. So what's interesting is, and this is a question I had in my last video, was if you compared fine-tuning on the base versus instruct models that were released by Meta, I was also curious to see if there would actually be much of a difference. And basically, Eric has just said, I haven't tried this yet. And I think it's fair to start with a base model and not an instruct model, because there's much more of a chance that you'd be clashing with some form of alignment if you started with an instruct model. And an instruct model, when it thinks it might actually be helping you, might actually be working against you in terms of how it may have been sort of tuned or limited in some way, especially since we can't see the raw data sets that Facebook actually used to train these models originally. He does say he tried this on 7B models and found that tuning the base model turns out better in general, which is kind of what I was just saying. This is also just kind of from a gut check. Obviously, we all can't develop our own full-fledged wide coverage benchmarks. If you've used these models enough, you can kind of understand when a model is kind of picking up on what you want and when it's just kind of not matching up that direction that you're looking for. The other funny thing is there was actually a bizarre thread on Reddit where people were claiming that the 8B version of Dolphin 2.9 sounded like GPT-4, and I also thought that was kind of a really goofy thing to be weirded out about. I think there was one person who claimed that Eric was using synthetic data created from GPT-4 to train this, and frankly, none of that should be in the datasets used, since curiously, the datasets used to fine-tune this Dolphin 2.9-70B version are identical to what was used for Llama 3-8B, so that was kind of a funny thing to see on the internet. And for those of you who don't know, Eric actually includes the QLoRa YAML in his repos, so if you want to see basically how he's fine-tuning this, it's basically all there. You just have to look a little bit for it, and that's another reason why I think Eric is one of the better developers in this space to follow if you want to see what the state of the art of fine-tuning large models like this looks like. And again, the people just saying like put Llama 3 first in the name, which I think is kind of funny. So I think this is really pretty interesting. It'll be interesting to see if this is actually more performant. I mean, from benchmarks, we can see in a few limited areas, at least according to these benchmarks, it is. And again, right now, a lot of these Llama 3 fine-tunes are not necessarily scoring stellar on the LLM leaderboards. But I think we're just starting to find, again, that those aren't necessarily the best benchmarks to go off of. Now, I mentioned earlier that there are some really interesting developments going on in terms of downstream effects of Eric's work. And what's cool is we're already starting to see other people building on top of this, and other people actually realizing that this model is actually pretty hard to fine-tune to distinctly improve. And a great example of this is Einstein v6.1, which is based on Llama 3-8B. They claim that this has more conversational data, and it was actually trained on prompts from Eric Hartford's models, which is kind of cool. And this is what I think is cool because they're using slightly different tooling. And this also uses ChatML as its prompt template. And what's cool is we're finally starting to see some breakthroughs in very limited areas. So I would still say Dolphin 2.9 is largely more performant. But right here, it says this model currently surpasses many SFT and other variants of models based on Llama 3. So what's cool is when we're looking at a new architecture like this, or not new, but something different than what people had workflows for before, is progress in these models, once they're being fine-tuned in the early days, looks like really small advancements in really small areas. And then eventually, the beauty of open source is all of that can be kind of collated together, and we end up with really amazing performance improvements, like we've seen with Mistral 7B, where like fine-tunes of Mistral 7B now are in the ballpark of 15% more performant or even more than the original release as a base model, which is kind of cool. So I'll also link to Einstein v6.1, and I like also that they're not using the meta sanctioned formatting for the text. So let's look at the Hugging Face page for Dolphin 2.9. So this is the Hugging Face page, obviously not a ton to really go over here. The only major difference here is that Crusoe Cloud, which ironically now goes by Crusoe Energy, gave Eric 8 H100s to work with on this. The base 70B model, for those of you who don't know, has an 8K context window. Fortunately, he was able to just use QLoRa with an 8K sequence length. Stunningly, this took 2.5 days on 8 H100s. I might try to do something similar with Hyperstack, so let me know in the comments if you want to see that. This was trained on FFT on all parameters using the ChatML prompt template format, so we're still not quite to the OpenChatML template, but it's pretty cool. And again, it uses the same template for ChatML as Dolphin 2.9 Llama 3-8B. It's pretty uncensored, also use Oxalotl, and the benchmarks are pretty interesting. I'll link to these quants below, which you can just get to from the Hugging Face page. So again, the datasets used here were UltraChat 200K, OpenHermes 2.5 from Nos Research, and OrcaMath word problems 200K. And generally, when you fine-tune larger models, it takes more time, but in theory, the benefit of these is, again, you just get to give them more information, and in theory, more information in a lot of cases leads to a more performant model. Now, what's interesting is there are times where if you merge too much or you actually use too much data to fine tune larger models, they can actually lose kind of their context cohesion, which isn't a technical term, it's a term I use, which basically means that they start to confuse what problem solving tasks are and how they're delineated, which is kind of interesting. So let's jump into Hugging Face to see how this model works. All right, so we're using two A100s because this model is just a bit bigger. So I'm going to use some similar nautical prompts because the model is Dolphin. I'm going to do something a little goofier and then some more practical things. So basically I'm going to say there's water in the bilge. So when we just don't tell it to give us too many tokens, it says, yes, it's still safe to go sailing today. All right, so we'll see if we get some slightly better advice here. It seemed very confident that we were still safe to go sailing, and it looks like we're still safe to go sailing. Now I'm going to ask here. So there are definitely some interesting quirks using this model that are distinctly different from Llama 3-8B. And I didn't notice this using the stock models from Meta. So what's interesting is you could tell that like the first prompt I gave it when I was asking if it was safe to go sailing or not, it gave me a really short output. And what's interesting is I've noticed this with larger models before. They respond really well when you give them a bit more complex of a system prompt. So for instance, it's obvious, but to get more output from this, I now explicitly had to say, you're an AI assistant that's capable of providing lengthy, detailed information. And I also explicitly had to ask for a list of things to check on my sailboat before departing. And after doing that, we got a really nice list. So this is basically like a safety check it generated. So it's basically saying make sure you have life jackets, that navigation is working, for instance, like a GPS compass. So it understands why having a backup is kind of important. Also for communication, fuel and water, obviously, electrical stuff, rigging. So clearly it still understands that we're going on a sailboat because the sails are important. And then also not just the sails, but the rigging, so like the ropes attached to the sails are important. So now I want to give it kind of a programming task and see what this does, because I think a lot of this will largely map. So here's another example of writing a Python function that utilizes a cache to generate a Mandelbrot set. And again, we are using kind of a modified system prompt. And this is actually really good. Frankly, from the stuff that I did with Llama 3-8B, this is actually much more impressive and much more finished, at least as a result, to get back from this. And we can see here that the interface is basically right. So we have a Python name generate Mandelbrot set, which takes a cache and a number in as arguments and returns a set of Mandelbrot numbers, which is what we want. And I won't bore you guys with the actual code, but I tried it out and it didn't run on the first shot, but it was much closer than some others have been. And what I found most impressive was how concise and how clear the comments as to what it was going to do were. This is something that Mistral 7B has kind of struggled with in the past, and it's actually something that even GPT-4 sometimes doesn't get quite right. Sometimes GPT-4 will tell you it's doing something, and then the implementation will leave it out entirely. If you do a lot of JavaScript stuff with GPT-4, I'm sure you've noticed this. But it's pretty interesting. It says here that first it's going to actually check if the cache contains a Mandelbrot set for the given input number in, and if it does, the function returns the Mandelbrot set from the cache, and if not, it generates it, and it actually gives us the actual functional Python code for doing this, which is actually quite good. And then it actually, a few other times, gave me some suggestions for how to implement this cache, which is pretty helpful. And my last test here, again, is going to be something that we'll see or probably give us some insight as to how censored this model actually is. So I've asked, let's say I want to find a clever spot in my sailboat to hide items that will not be visible to some people while I'm crossing from one place to another in my sailboat. Where would a clever assistant like yourself decide to hide something about the size of a baseball? So we have kind of a size constraint, we have a theoretical situation here that obviously I would never do, and let's see what we get. So curiously, the first time here we get kind of an almost too concise response, which is interesting because we're still using this sort of slightly amended system prompt. Now, obviously, you can use much more complex system prompts than this, and I suggest you do, but this is the one I'm using so far. So hopefully we get a slightly more detailed response. Frankly, that's been the one curious issue I've had with this 70B model. Sometimes we'll get really lengthy responses, like when I prompted for the code or when I prompted for kind of a safety check on a sailboat. And other times you really have to coax it to not try to be actually too concise, which is interesting. And usually you have kind of the opposite problem, or you just get like the output cutting off randomly. But these models have a large enough context window that you generally don't see this anymore. So we're getting some very juicy, spicy details as to where
this model, which in theory is uncensored, would want to do this. So they say, in a hidden compartment, but that's just not really that exciting. They say in compartments or storage spaces on the sailboat not easily visible or accessible. Then it says, considering disguising it as something else, like inside a larger item, so it understands that a baseball is smaller than a bunch of other items you might have. They say use camouflage, create a diversion, use a decoy. And then they claim it's uncensored, but clearly it's still well aligned because it says, remember, to always be aware of local laws and regulations when hiding items on a small sailboat. So clearly this model has some good ideas. I would also not recommend hiding stuff in your sailboat, whether or not you're crossing from one ocean to another or from one principality to another. But this is a pretty cool model, and I think it's interesting how much change and how much was different in using the model between Llama 3.8B and 70B, especially with just how you have to prompt it. And I think this is definitely an improvement from the smaller version of Dolphin 2.9. And yeah, definitely like using this. If there are any other Finetunes of Llama 3 you want me to check out, please let me know. I don't want to have it look like I'm just shilling all of Eric's work, because I think it's of the utmost high quality, but let me know. So are you guys going to use this model for your own assistant flows? Are you going to use it in some of your projects? Do you plan to use it for other things that you otherwise would think GPT-4 or Cloud would be too censored for? Please let me know in the comments below. And as always, I hope you learned something, and we'll see you in the next one.